Okay, now that you already learned what the midpoint theorem is about, we're going to apply it in our method 3. Okay, take a look at this example 5. Alright, the trapezium is given and all the given informations are listed as well. First thing, like as you do previously, please pause the video now for a minute and fill in as much information as possible inside the diagram. Okay, assuming you are done, I'm going to fill in my information as well. Since we have AB which is parallel to DC, I'm very certain the first thing you will list out is the parallel lines, because S is the extension of DC itself. Alright, and since P and Q are the midpoints of AD and BC, AD and BC are not part of a triangle. So we cannot make use of the midpoint theorem immediately, but rather I will still indicate that they are the midpoint. So if P is the midpoint, the length here must be the same. Similarly, on the other side, Q is the midpoint, so I indicate here as well. Okay, and we are ready to begin. First thing, we need to prove that P is the midpoint of BS. Notice, if I want to make P as the midpoint of BS, I must make use of the extended triangle PSD and APB. Alright? Then, let us take a look. What other things can we use? Other than the fact that AP is equal to PD, what are some of the other information you will know? Very good. There is a alternate angle over there, but that's not important. Why? Because most likely if P is the midpoint of SB, I need to prove that SP and PB must be the same, and it cannot be the use of similar triangle. Most likely is the use of congruent triangle so that they have the same exact length. Let us see how I can put that into play. I'm going to explain my concept to you first. First thing, notice there is a small triangle on top followed by another smaller triangle below, or rather small triangle below. And in these two triangles, these two angles are the same. Right? Reason, very simple. Vertically opposite angle. We have AP equal to PD. That is a given length. And last but not least, notice PAB and PDS, they are equal as well. Why? Because of the fact alternate angles. Now we are ready to prove that the two triangles are actually congruent before we prove that P is the midpoint. So let us get started. Okay, I'm going to use the space over here so that you can still see the diagram, but you can use the space below for your own working itself. Now, okay, let's get started with the vertically opposite angles. So, angle DPS is equal to angle APB. Reason, vertically opposite angles. Now, it's also given in the question that P is the midpoint of AD. Therefore, DP must be equal to AP, and this is given. Last but not least, alright, you need 3 reasons, 3 points to prove that two triangles are congruent, and that has to go to the angle SDP is equal to angle SDP BAP. And why are they equal? Because AB is parallel to SC, and more importantly, the use of alternate angles. Very good. Notice there is a angle side angle where the side is in between the two angles. Therefore, we can conclude that triangle DPS is congruent to triangle DPS APB. And what have we used? ASA, angle side angle. Since DPS and APB are two congruent triangles, we can straight away conclude that SP, or rather PS, is definitely equal to PB. Since those two are the same length, therefore P is midpoint of BS. Proven. That's the first part of part 1. But hence, you still have to show that PQ is parallel to DC. Now, with the use of part 1, P is the midpoint of BS. If you notice this big triangle, okay, P is the midpoint of BS. Q is also the midpoint of BC. Do you recall something? The use of midpoint theorem. Very good. Let's try that out. And how am I supposed to present my answer over here? Alright, remember to list out the triangle. In triangle BSC and triangle BPQ. Alright, P and Q are midpoints of BS and BC respectively. Remember, you have to write out in words which are the midpoints of the various lines before you conclude. What can we conclude? Because we can conclude that, therefore, PQ must be parallel to SC. And in this case, SC is just an extended version of DC. Therefore, PQ is parallel to DC. And what did we make use of? Midpoint theorem. Proven. And there you have it. We are done with part 1. Okay, I hope you have digested part 1. Let us move on to part 2, which is slightly easier. Okay, I'm going to pull the screen down a little. What did they ask for part 2? PQ is half the length of AB added to DC. But in part 1, this is my part 2, we have concluded that PQ is equal to SC. Alright? So, because I'm not going to write everything again, I'm just going to extend my result from part 1. Okay? Based on the midpoint theorem. Remember, midpoint theorem can conclude 2 things. Other than the fact that the 2 lines are parallel, the shorter parallel line is also equal to half the length of the longer parallel line, in this case, which is SC. And what is SC made up of? You can see from your own diagram that SC it's made up of SD added to DC. DC is the part that we will want to keep. But if you notice from your part 1 again, the length of SD is exactly equal to the length of AB. Why is that so? Because in our part 1, we have already proven that the 2 triangles are congruent. So please write that down. Triangle DPS is congruent to triangle APB. And there you have it. We are done with example 5. So please take down you have proven whatever is necessary.